This video will show you how to get t star without having the function inverse t. Most students have in their classrooms a TI-83 graphing calculator, which does not come equipped with the inverse t function like the TI-84s do. And if you don't have that inverse t, then unfortunately you would not have an easy way to calculate t star. I'm going to show you multiple ways that you could go about that without the inverse t function. The t star would mainly be needed when you are calculating a t interval, which has the following formula. Now, obviously, even if you have a TI-83, you can calculate the t interval without actually having to do t star by itself. But there are various problems that do require you to find a t star, or multiple choice questions that require you to find a t star. Let's just do a basic example. Let's just say that I had a sample size of 45, and the sample found an average of 71 with a standard deviation of 4, and I needed to calculate a 95% confidence interval. Now, first, if you just had to calculate the confidence interval, after hitting all the assumptions and conditions, you would type in the appropriate information, calculating that 95% confidence interval, which would give you an interval of 69.798 to 72.202. Now, if you had to calculate t star by itself for this problem, if you had an TI-84 calculator, you would go inverse t. T star would be equal to inverse t 0.975, comma 44 for this example. The reason for that is because if you are finding a 95% confidence interval, you are excluding 5%, which is split symmetrically between the two, 2.5%, 2.5%, which would put you at the 97.5th percentile. 44, because of the degrees of freedom, that would give you a t star of approximately 2.0154 if I had to round it. Now, there is a way to calculate inverse t by working with the interval backwards. If you were able to calculate the t interval, then you can easily work backwards to get the margin of error, and then, of course, the t star. 69.798 to 72.202. If I were to go 72.202 minus 71, that would give me a margin of error of approximately 1.202. Now, that margin of error, 1.202, is approximately equal to t star times the sample standard deviation over the square root of the sample size. If I were to do that, let's see, I would have to divide both sides by that fraction. 4 divided by the square root of 45 would give me a t star. And again, this is a little bit of rounding error because of that margin of error being rounded. But that gives me a t star of approximately 2.016 if I had to round that. Another way of potentially calculating t star without having to go through that process is by using your t interval and manipulating the numbers that go inside. For example, our sample size should remain the same, but if you let x bar equal 0 and s equal the square root of 45, then your t interval formula, which was x bar plus or minus t star times s over the square root of n, turns into 0 plus or minus t star times the square root of 45 over the square root of 45. That forces your standard error to be 1, and the resulting interval would just be your negative t star to your positive t star. if you're trying to calculate that t-star, you could let x bar equal 0, standard deviation be the square root of the sample size, 95% confidence, and it calculates an interval from negative t-star to positive t-star, approximately 2.0154, which again is similar to what we got before, but the other one was a little bit of rounding error. This one's obviously much more accurate. The last way that I can show you to calculate that t-star without having inverse t is by using the chart that is given to you on the AP test. Now, this particular chart shows the t distribution. And what I would like to point out is that the degrees of freedom on the left don't match up with the sample size that we have. We had a sample size of 45, giving us a degrees of freedom of 44, which obviously are between these two numbers. Now, if I scroll down just a little bit, at the bottom of this chart gives you the confidence level that you're looking for. 95% confidence, line it up right here between 40 and 50 degrees of freedom. Now, we had 44 degrees of freedom. It's somewhere between 2.021 and 2.009. Not precisely between those two, but very close to that. 2.021 plus 2.009. Let me switch back to my top-down. Now, you won't be able to do this every time, but because it just happens to be in between, I get a t-star of approximately 2.015. If you were using this for a different degrees of freedom, obviously, if you were anywhere between 1 and 30, you could easily find your degrees of freedom value, but anywhere beyond that, you're just going to have to estimate or go to the closest value. I could probably use 2.015 or 2.021, and it would be justified on the AP test. If you have any questions, please leave those in the comments below, and do not forget to like and subscribe.